Hi, this question is from Google. Basically, okay, I'm copy paste to here. So you're given a queue, class Q, and then there's a pub and it's empty. So you give it a list. It has to be a list of Q, and they contain all of the positive integer. And you give it the size of Q, the length of a Q, and you want to find out the shortest Q for the size. Basically, so it's going to be a list of Q1, Q2, and then all until Qn. You want to find the shortest. So in each Q, you're going to traverse. So this is the items, I1, I2, and then all the way to IX, right? And this might be I1 all the way to IM, something like this, right? Traverse a queue, find out how many size or how many items in the queue, and then basically just keep updating. If this is size is smaller than whatever you record for the return answer. So it's going to be pretty straightforward. Mean size, mean index. So this is going to be like a temporary value to keep storing whatever the size you currently have. Mean index represents the index that you're going to return. So in the queue, this has to be list, right? So I traverse the list for this guy. Every single index, I basically get it, and then I get it, I traverse and then pop and check if a queue is empty. If not, then I keep traversing and keep adding the size until the queue is empty. I check with my global variable mean size. If this is less than, I'm updating my mean size to the current size of queue, and then update the index, and then traverse until this finish. So that's pretty straightforward for UMA. So for the main question, you're going to find out the minimum sum in the list. In the list of queue. So in the most efficient manner. So in this case, right, what does list mean? Technically, it means nothing. Why? Because you can have one queue, so Q1. You can have one queue only for two items. Let's just say 1, comma, and this is 1 million. And you might have another queue which is going to be 1, 2, 3, size of 3, but the sum of the Q2 is less than sum of Q1. So how do you know which one is smallest? You need to traverse until the end, right? So again, basically doing the same thing. Mean sum represent the sum you have for this function. Traverse the queue size, I get it, and this is basically a running sum for the current queue. And every single time I set equal to 0, and then prune equal to false. So if you traverse this queue, and then after you traverse, you still not setting your prune equal to true. So how do you set the prune equal to true? When you adding your pop of adding every single items in the queue, if this one current sum is greater than min sum, then you will actually return true and then break. So you don't need to traverse because you already know this current queue doesn't work, right? So if this is not prune, so which is still a false, and then prune will less than min. So after you traverse the value, and then the running queue, the running sum is less than min. The min sum I update it and then I return. So this is actually the way you're trying to resolve this question. So basically you cannot just check the size. If you just check the size, it's not accurate. It has to be the actual value in the queue. So that's pretty much it. Alright, see you, man.